In the mid-20th century, humanity stood on the precipice of a new era of exploration and discovery, one that would take them beyond the confines of Earth and into the vast reaches of space. This era, known as the space race, was not just a pursuit of scientific knowledge, but a symbolic and ideological battle between two superpowers, the United States and the Soviet Union. Each nation sought to prove its dominance in technological prowess, military strength, and political ideology. Yet, amidst the tensions of the Cold War, this competition would lead to one of the most remarkable achievements in human history: landing a man on the moon. The roots of the space race can be traced back to the aftermath of World War II, a time when both the U.S. and the Soviet Union emerged as global superpowers. The Cold War between them would define the political landscape of the latter half of the 20th century, and space exploration became one of its most visible arenas. The idea of reaching space had long captured the imagination of scientists, writers, and dreamers. But it wasn't until the late 1950s that this dream began to take shape as a reality. The starting point of the space race came on October 4, 1957, when the Soviet Union shocked the world by launching Sputnik 1, the first artificial satellite, into orbit around the Earth. Sputnik was a small metallic sphere with 4 long antennae, broadcasting a simple radio signal as it orbited the planet. Its significance, however, was far greater than its size. The launch of Sputnik marked the beginning of the space age and demonstrated that the Soviet Union had developed the technology to launch objects, and potentially weapons, into space. This achievement sent shockwaves through the United States, which suddenly found itself behind in a critical technological race. In response, the U.S. government quickly realized the strategic and symbolic importance of space exploration. Just 1 year after the launch of Sputnik, President Dwight D. Eisenhower established the National Aeronautics and Space Administration, NASA, an organization dedicated to the peaceful exploration of space. NASA's mission would be to catch up to the Soviet Union and ultimately surpass its achievements, pushing the boundaries of human knowledge and engineering. The next major milestone came in April 1961, when Soviet cosmonaut Yuri Gagarin became the first human to travel into space and orbit the Earth aboard his spacecraft, Vostok 1. This remarkable achievement was another blow to American pride and a major propaganda victory for the Soviet Union, which portrayed itself as the leader of space exploration and scientific progress. Gagarin's flight was celebrated around the world, and his name became synonymous with human achievement in space. In the United States, the pressure to respond grew stronger. It was clear that the nation needed to make a bold statement in space exploration, one that would not only restore its prestige but also demonstrate the superiority of American technology and ingenuity. Just weeks after Gagarin's historic flight, on May 25, 1961, newly elected U.S. President John F. Kennedy stood before a joint session of Congress and made a bold and ambitious declaration. I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. Kennedy's speech electrified the nation. The goal he had set was nothing short of extraordinary. At the time, the United States had only just begun sending astronauts into space, and the idea of landing a human being on the moon seemed like science fiction. Nevertheless, Kennedy's words ignited a national sense of purpose, and NASA embarked on an ambitious and unprecedented program to make the moon landing a reality. This program, known as Apollo, would become one of the most significant undertakings in the history of science and technology. The Apollo program faced immense challenges, both technical and financial. The vast distances involved in a moon mission, the need for advanced rockets, spacecraft, and life support systems, and the sheer complexity of navigating in space all represented obstacles that had never been faced before. Yet, despite these difficulties, the U.S. poured enormous resources into the effort, driven by a mixture of national pride, scientific curiosity, and the desire to outpace the Soviet Union. As NASA began to develop the hardware and expertise needed for a moon mission, the space race continued to unfold in other areas. The Soviets achieved another victory in 1965 when Alexei Leonov became the first human to conduct a spacewalk, venturing outside his spacecraft in the vacuum of space. The U.S. responded with its own achievements, including the development of the Gemini program, which tested crucial technologies such as space rendezvous, docking, and long-duration missions, all essential for a successful moon landing. By the mid-1960s, the competition between the two superpowers was at its peak, and the world watched as each nation pushed the limits of what was possible. The tension of the Cold War continued to drive innovation, as the race to the moon became more than just a technological challenge. It became a symbol of ideological victory. For the United States, landing a man on the moon was not just about exploration. It was about demonstrating the power of democracy, freedom, and capitalism in the face of Soviet communism. Yet, despite the fierce competition, the space race also brought with it a sense of wonder and possibility. It was a time when humanity was on the cusp of venturing beyond its home planet, exploring the unknown and reaching out to the stars. The moon, a distant and mysterious object that had fascinated humans for millennia, was now within reach. The promise of landing on the moon represented a leap into a future where anything seemed possible. As we journey through the story of the Apollo program and the moon landing, we will explore the incredible challenges, triumphs, and legacy of this historic event. From the creation of the Saturn V rocket, to the fateful launch of Apollo 11, to the moment when Neil Armstrong set foot on the lunar surface, the moon landing was not just a victory in the Cold War, it was a victory for all of humanity. A moment that united the world in awe of what we can achieve when we dream big and work together. Chapter 1. The Apollo Program Begins. With President John F. Kennedy's bold declaration in 1961 to land a man on the moon before the end of the decade, the United States embarked on one of the most ambitious and complex programs in the history of human exploration, the Apollo program. It was an endeavor that would push the limits of science, technology, and human endurance, ultimately culminating in the successful moon landing in 1969. But this monumental achievement was the result of years of painstaking effort, triumph, and tragedy. NASA's task was daunting. Landing a man on the moon would require the development of technology that had never existed before, from rockets powerful enough to break free of Earth's gravity to spacecraft that could carry astronauts safely to the lunar surface and back. The Apollo program's success would depend on perfecting every element of spaceflight, from navigation to life support systems, all under the pressure of the Cold War's relentless competition. The Apollo program was built on the foundations laid by earlier space missions, particularly Project Mercury and Project Gemini. The Mercury program had demonstrated that humans could survive in space, with missions that put American astronauts like John Glenn into orbit. These early missions were critical in understanding how the human body reacted to the conditions of space, but they were just the beginning. The more advanced Gemini program took these lessons further, focusing on long-duration flights, spacewalks, and docking maneuvers, all essential skills for the moon landing. As NASA developed its plans for Apollo, it became clear that the journey to the moon would require a new kind of spacecraft. The mission would involve three main components: a command module, where the astronauts would live and control the mission; a service module, which provided propulsion and life support; and a lunar module, a specialized spacecraft designed to land on the moon and then launch the astronauts back into orbit for their return to Earth. But even with this vision in place, the challenges were immense. One of the first and most significant hurdles was the design of a rocket powerful enough to send the spacecraft to the moon. This led to the development of the Saturn V, a massive rocket that would become the backbone of the Apollo program. Standing over 360 feet tall and weighing more than 6 million pounds, the Saturn V was the most powerful rocket ever built, capable of generating 7.5 million pounds of thrust. It was a technological marvel, and its success was crucial to the moon landing. The early stages of the Apollo program were marked by a mixture of progress and setbacks. In 1967, disaster struck with the tragic loss of Apollo 1. During a routine pre-launch test, a fire broke out in the command module, killing all three astronauts aboard: Gus Grissom, Ed White, and Roger Chaffee. The fire was a devastating blow to NASA and the Apollo program, highlighting the dangers inherent in space exploration. The tragedy led to a complete overhaul of the spacecraft's design and safety protocols, as NASA worked to prevent such a catastrophe from ever happening again. Despite the heartbreak of Apollo 1, the program continued. The next few years were dedicated to testing and refining the technology that would eventually take humans to the moon. Apollo 7, launched in 1968, was the first successful manned mission of the program. Its primary goal was to test the command and service modules in Earth's orbit, ensuring that they could function as intended. The mission was a success, restoring confidence in the Apollo program after the tragedy of Apollo 1. Following Apollo 7, NASA conducted a series of missions that progressively tested the various elements of a moon landing. Apollo 8 marked a major milestone, as it became the first manned spacecraft to leave Earth's orbit and travel to the moon. While Apollo 8 did not land, its crew, including astronauts Frank Borman, Jim Lovell, and Bill Anders, orbited the moon and provided humanity with the first glimpses of the lunar surface from up close. It was during this mission that the iconic Earthrise photograph was taken, capturing the Earth as a small blue and white sphere rising over the moon's horizon. This image became a symbol of the fragility and unity of life on Earth, viewed from the vastness of space. With each mission, NASA moved closer to its ultimate goal. The success of Apollo 9 and Apollo 10 further refined the techniques needed for a lunar landing. Apollo 9 tested the lunar module in Earth's orbit, while Apollo 10 conducted a full dress rehearsal, sending the lunar module to within 50,000 feet of the moon's surface before returning to the command module. These missions demonstrated that all the pieces were in place for a successful moon landing. The technology had been tested, the astronauts were trained, and the mission plan had been perfected. By 1969, the stage was set for Apollo 11, the mission that would finally fulfill President Kennedy's ambitious goal. The world watched with anticipation as NASA prepared for what would become one of the most significant moments in human history. The Apollo program's journey to this point was one of innovation, perseverance, and determination. It had overcome the technical challenges of space exploration, the tragedy of Apollo 1, and the immense pressure of the Cold War. Now, all that remained was the final step, the landing itself. Chapter 2: The Saturn V Rocket and the Launch of Apollo 11. By 1969, NASA had overcome immense technical, political, and human challenges to prepare for the moon landing. At the heart of the Apollo mission lay the Saturn V rocket, a towering marvel of engineering and the most powerful rocket ever constructed. Without it, the dream of landing a man on the moon would have been impossible. The Saturn V wasn't just a machine. It was a symbol of human ingenuity and determination, standing over 360 feet tall, taller than the Statue of Liberty, and capable of carrying the weight of history on its massive shoulders. The Saturn V was developed under the guidance of Wernher von Braun, a former German rocket scientist who had been instrumental in the creation of the V-2 rocket during World War II. After the war, von Braun and many of his colleagues were brought to the United States under Operation Paperclip, where they began developing rocket technology for the U.S. military and later for NASA. Von Braun's visionary leadership was essential in the creation of the Saturn V, a rocket that would deliver not just payloads, but also the hopes of a nation. The design of the Saturn V was revolutionary. It was a three-stage rocket, each stage designed to take the spacecraft closer to the moon. The first stage, powered by 5 F-1 engines, generated 7.5 million pounds of thrust, enough to lift the massive rocket off the ground and propel it through the thickest part of Earth's atmosphere. The second stage, with 5 smaller engines, would then take over, accelerating the rocket to higher altitudes and faster speeds. Finally, the third stage, with a single J-2 engine, would propel the Apollo spacecraft into orbit and then on a trajectory toward the moon. Months of preparation and testing went into every aspect of the Saturn V, from the engines to the fuel systems, to the guidance controls that would ensure the rocket reached its precise destination. Each part of the rocket had to function perfectly. There was no room for error. As the date of the Apollo 11 mission approached, the tension mounted at NASA's Kennedy Space Center in Florida, where engineers, scientists, and astronauts made their final preparations for the historic flight. On the morning of July 16, 1969, the world held its breath as the Saturn V stood ready on Launch Pad 39A. Atop the rocket sat the Apollo 11 spacecraft, containing 3 astronauts, Neil Armstrong, Buzz Aldrin, and Michael Collins. Armstrong, the mission commander, would be the first person to walk on the moon. Aldrin, the lunar module pilot, would join him on the surface, and Collins, the command module pilot, would remain in orbit around the moon, ensuring the safe return of the crew. As the countdown began, the anticipation was palpable. Hundreds of thousands of spectators gathered near the launch site, while millions more watched on television around the world. For the astronauts, the moment was the culmination of years of intense training and preparation. They had spent countless hours in simulators, learning to operate the spacecraft and practicing for every possible scenario. Now, the time had come to put their skills to the ultimate test. At 9:32 a.m. Eastern Daylight Time, the engines of the Saturn V ignited, and a roar like no other filled the air. The ground shook, and the massive rocket slowly lifted off the launch pad, climbing into the sky with a trail of fire and smoke behind it. The spectacle was awe-inspiring as the Saturn V ascended through the atmosphere, defying gravity with sheer power and precision. For the first time, human beings were on their way to the moon. Inside the spacecraft, the three astronauts felt the incredible force of the rocket's acceleration as they were pressed back into their seats by the G-forces. The launch was intense, but it went smoothly. Each stage of the rocket fired as planned, and within minutes, Apollo 11 was in Earth's orbit. The crew's task was far from over, however. After a few orbits around the Earth to check that all systems were functioning properly, the third stage of the Saturn V reignited, sending the spacecraft on its translunar injection, the maneuver that would send them hurtling toward the moon. For the next 3 days, Apollo 11 traveled through the vacuum of space, covering the roughly 240,000 miles between Earth and the moon. During the journey, the astronauts conducted routine system checks and made observations, but much of their time was spent simply waiting for the moment when they would arrive at their destination. They passed the time in the cramped quarters of the command module, which, although technologically advanced, offered little in the way of comfort. As they neared the moon, the crew prepared for the next critical phase of the mission, separating the lunar module from the command module. The lunar module, named Eagle, was a lightweight spacecraft designed specifically to land on the moon. While Armstrong and Aldrin would descend to the lunar surface in Eagle, Collins would remain aboard the command module, Columbia, orbiting the moon and awaiting their return. The mission was entering its most dangerous phase. Any number of things could go wrong, from technical malfunctions to human error. The lunar module's descent engine had to fire perfectly to slow the spacecraft as it approached the moon's surface. Once there, Armstrong and Aldrin would have to land with pinpoint accuracy on the relatively flat area of the Sea of Tranquility, a lunar plain chosen for its safety and suitability for landing. The world watched in anticipation as Apollo 11 entered the moon's orbit on July 19, 1969. The mission was going according to plan, but the most difficult moments still lay ahead. The next day, the Eagle would attempt to land on the moon, and history would be made. The Saturn V had done its job flawlessly, launching Apollo 11 into space and carrying it across the vast distance to the moon. It was a testament to the power of engineering, innovation, and the human spirit. But the mission was far from over. Armstrong, Aldrin, and Collins now faced the ultimate test: landing on the moon and returning safely to Earth. Chapter 3: The Lunar Journey and Moon Landing. After traveling through the vastness of space for 3 days, Apollo 11 and its crew arrived in lunar orbit on July 19, 1969. The spacecraft was now circling the moon, and the astronauts, Neil Armstrong, Buzz Aldrin, and Michael Collins, could see the barren, cratered surface passing beneath them. They had come farther than any human beings had ever ventured before. Now, the moment of truth was approaching. Soon, Armstrong and Aldrin would attempt something that had only been imagined in the realm of science fiction: landing a manned spacecraft on the surface of the moon. The plan was meticulous. As Apollo 11 orbited the moon, the lunar module, Eagle, would separate from the command module, Columbia. Armstrong and Aldrin would pilot Eagle down to the surface, while Collins, in Columbia, remained in lunar orbit, ensuring that everything went smoothly and preparing for their eventual return. It was a risky operation. If anything went wrong with the descent or ascent, Armstrong and Aldrin could be stranded on the moon with no hope of rescue. On the morning of July 20th, 1969, the mission reached its critical phase. Eagle separated from Columbia, and Armstrong and Aldrin began their descent toward the lunar surface. In the control room at NASA's Mission Control Center in Houston, the tension was palpable. Years of preparation, countless hours of testing, and the dreams of an entire nation rested on the success of this moment. The world watched in anticipation as the lunar module slowly made its way down. But the descent was not without challenges. As Eagle approached the surface, Armstrong and Aldrin realized that their intended landing site was filled with boulders and craters, an unsafe area for a touchdown. With fuel running low and alarms sounding in their spacecraft, Armstrong had to take manual control of the landing. His calm demeanor and extraordinary piloting skills would make all the difference in those tense moments. With less than 30 seconds of fuel remaining, Armstrong guided Eagle past the hazardous terrain, searching for a flat, open area to land. Finally, at 4:18 p.m. Eastern Daylight Time, Armstrong's voice came crackling over the radio. "Houston, Tranquility Base here. The Eagle has landed." Those words signaled the successful landing of the lunar module in the Sea of Tranquility, a relatively smooth and flat plain on the moon's surface. For the first time in history, a human spacecraft had landed on another celestial body. Applause erupted in Mission Control, and around the world, people celebrated the remarkable achievement. After checking the systems and ensuring that Eagle was secure, Armstrong and Aldrin prepared for the next historic step. The astronauts suited up in their bulky extravehicular mobility units, EMUs, spacesuits designed to protect them from the moon's harsh environment. These suits provided life support, temperature regulation, and mobility, enabling the astronauts to survive in the vacuum of space. At 10:56 p.m. Eastern Daylight Time, after climbing down the ladder of the lunar module, Neil Armstrong became the first human to set foot on the moon. His words, broadcast live to an estimated 600 million people around the world, echoed through history. That's one small step for man, one giant leap for mankind. The world watched in awe as Armstrong's boot pressed into the fine lunar dust, leaving the first human footprint on the moon's surface. It was a moment of profound significance, not just for the United States, but for all of humanity. In that instant, the impossible had become possible. Shortly after Armstrong's historic step, Buzz Aldrin followed, joining him on the surface. Aldrin famously described the lunar landscape as magnificent desolation, a place unlike anything on Earth. Together, Armstrong and Aldrin spent over 2 hours exploring the moon's surface, conducting experiments, collecting samples, and taking photographs. They set up the American flag, symbolizing the triumph of the Apollo mission, and left behind a plaque bearing the inscription, "Here, men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind." Among the experiments they conducted was the deployment of a seismometer, designed to measure lunar activity, and a laser reflector, which scientists on Earth could use to measure the precise distance between the Earth and the moon. These experiments would contribute to humanity's understanding of the moon and its environment. As they worked, Armstrong and Aldrin marveled at the sight of Earth from the moon. It appeared as a distant blue and white orb, hanging in the blackness of space, a fragile planet that now seemed both vast and small. The perspective of seeing Earth from the moon gave the astronauts and the world a new appreciation for the planet and for the shared experience of being human. Back on Earth, people around the globe were captivated by the images and sounds being transmitted from the moon. This was more than just a technological achievement. It was a moment of unity, a time when the boundaries of nations seemed to fade, and people of all backgrounds and cultures were brought together by the wonder of space exploration. The moon landing wasn't just an American victory. It was a triumph for humanity. After completing their tasks on the lunar surface, Armstrong and Aldrin climbed back into the lunar module, securing themselves for the journey back to the command module. With Collins waiting patiently in orbit, they had one final critical challenge: the ascent from the moon. Once again, everything had to go perfectly. The lunar module's ascent engine fired, lifting Eagle off the surface and returning the astronauts to lunar orbit, where they successfully docked with Columbia. The return journey was smoother, but no less significant. Apollo 11's mission was now nearing its conclusion. The crew had accomplished what many thought impossible. They had landed on the moon and returned to their spacecraft, ready to make the journey back to Earth. On July 24, 1969, Apollo 11 splashed down in the Pacific Ocean, where the crew was safely recovered by the USS Hornet. Their mission had been a resounding success. They had fulfilled President Kennedy's goal of landing a man on the moon and bringing him back safely to Earth, and they had done so ahead of schedule. The moon landing marked the pinnacle of the Apollo program and a defining moment in the history of human exploration. It was a victory not just for the United States in the Cold War's space race, but for all of humanity. It showed that, when united by a common goal, we are capable of extraordinary things. Chapter 4: The Legacy of the Moon Landing. The success of Apollo 11 in landing humans on the moon and safely returning them to Earth was more than a defining moment in space exploration. It was a milestone that forever altered humanity's relationship with the cosmos. The legacy of the moon landing is far-reaching, touching not only the fields of science and technology, but also inspiring generations to look beyond the Earth toward the stars. In this chapter, we will explore the enduring impact of the Apollo 11 mission, from its scientific contributions to its cultural and technological legacy. Scientific discoveries and contributions. One of the primary objectives of the Apollo missions, including Apollo 11, was to enhance our understanding of the moon. Armstrong and Aldrin brought back 47.5 pounds of lunar samples, including rocks, soil, and core samples from the moon's surface. These materials were carefully analyzed by scientists, providing insights into the moon's geological history, composition, and environment. The lunar samples revealed that the moon had experienced intense volcanic activity billions of years ago, which helped form its smooth plains known as Maria. The samples also suggested that the moon's surface had been heavily bombarded by meteorites over time, shaping the cratered landscape that is so visible from Earth. Additionally, the moon rocks contained evidence of a shared origin with Earth, leading to the widely accepted giant impact hypothesis, which suggests that the moon was formed when a Mars-sized body collided with the young Earth, sending debris into space that eventually coalesced into the moon. Beyond the physical samples, the experiments conducted on the moon, such as the Lunar Seismic Profiling Experiment and the deployment of a retroreflector, contributed significantly to our understanding of lunar and planetary science. The retroreflector, which remains in place to this day, allows scientists on Earth to precisely measure the distance between the Earth and the Moon by bouncing lasers off its surface. This has provided valuable data on the Moon's orbital dynamics and helped refine our understanding of Earth's gravitational relationship with the Moon. These scientific discoveries weren't limited to lunar geology. The Apollo program also expanded our knowledge of spaceflight, human endurance in space, and life support technologies. The advancements in rocket science, guidance systems, and propulsion developed during the Apollo program would pave the way for future space exploration, from crewed missions to the International Space Station to ambitious plans for Mars exploration. Technological advancements and spin-offs. The technological innovations developed for the Apollo program had a profound impact on many aspects of everyday life. NASA's collaboration with contractors and engineers resulted in breakthroughs that extended beyond space exploration and found applications in industries ranging from medicine to electronics. For example, the microchips developed to handle the computing needs of the Apollo spacecraft led to significant advancements in computer technology. The Apollo Guidance Computer, AGC, which helped control the spacecraft's flight paths and maneuvers, was a revolutionary piece of hardware that utilized integrated circuits. This technology played a crucial role in the development of modern computers, influencing the design of personal computers, smartphones, and countless other devices we rely on today. In the medical field, developments in miniaturized life support systems and monitoring equipment during the Apollo program inspired innovations in healthcare technology. Portable medical devices, such as heart monitors and defibrillators, trace their origins to the technologies created for spaceflight. Additionally, the development of insulation materials, like the gold-coated visors used in astronauts' helmets to protect them from harmful solar radiation, influenced the design of protective equipment in both medical and industrial settings. The moon landing also accelerated progress in communications technology. The ability to transmit live images and audio from the moon to Earth in real time was a remarkable achievement in the 1960s. This technology would evolve into the systems that today enable global satellite communications, internet connectivity, and television broadcasting. The improvements in signal processing, data transmission, and imaging laid the foundation for modern telecommunications infrastructure. Cultural and social impact. Beyond its scientific and technological contributions, the moon landing had a profound cultural and social impact, both in the United States and around the world. For millions of people, the Apollo 11 mission was more than just an achievement of the space program. It was a symbol of hope, possibility, and unity. In a time of political and social turmoil, including the Vietnam War, civil rights struggles, and global tensions, the moon landing provided a moment of collective pride and inspiration. The iconic image of Neil Armstrong's first step on the moon, accompanied by his famous words, "That's one small step for man, one giant leap for mankind," became an enduring symbol of human achievement. It was a reminder that despite our differences, humanity is capable of accomplishing extraordinary things when united by a shared goal. The Apollo program's motto, "We came in peace for all mankind," encapsulated the spirit of exploration and cooperation that the mission represented. The moon landing also inspired a generation of scientists, engineers, and explorers. Children who grew up watching the Apollo missions dreamed of becoming astronauts, engineers, or space scientists. The excitement surrounding the moon landing ignited a surge of interest in STEM, science, technology, engineering, and mathematics, fields, shaping the future of space exploration and technological innovation for decades to come. Culturally, the Apollo 11 mission left an indelible mark on art, literature, film, and music. The moon landing became a frequent subject of creative expression, symbolizing both the wonder of exploration and the technological achievements of humanity. Films like 2001, A Space Odyssey, which premiered just before the moon landing, and subsequent science fiction works explored the possibilities of space travel, reflecting society's fascination with the final frontier. The moon landing became a touchstone for human imagination, a representation of the boundless potential of our species. The future of space exploration. The legacy of Apollo 11 extends far beyond 1969, influencing not only the future of space exploration, but also the way we see our place in the universe. The success of the moon landing laid the groundwork for subsequent missions, such as the Apollo-Soyuz test project in 1975, which marked the first international space collaboration between the United States and the Soviet Union. This moment of cooperation during the Cold War hinted at the future of space exploration as a global endeavor. In the decades following Apollo, the focus of human space exploration shifted toward building the International Space Station, ISS, a collaborative effort involving space agencies from around the world. The ISS became a platform for long-duration space missions, research, and the development of technologies needed for future exploration of the Moon, Mars, and beyond. The spirit of Apollo continues to drive these missions, reminding us of the importance of exploration and international cooperation in advancing human knowledge. Looking ahead, the Apollo legacy lives on in modern space initiatives like NASA's Artemis program, which aims to return humans to the Moon by the mid-2020s. This time, the goal is not just to land on the Moon, but to establish a sustainable human presence there, preparing for future missions to Mars. The advancements made during the Apollo era remain foundational to these new efforts, as humanity continues its journey to explore the cosmos. A leap for all mankind. As we reflect on the legacy of Apollo 11, it's clear that the moon landing was much more than a technological triumph. It was a moment that united humanity in awe and wonder, a demonstration of what we can achieve when we come together with a shared purpose. The images of Armstrong and Aldrin walking on the moon, with the Earth hanging in the distance, reminded us of our collective place in the universe. A small planet in a vast cosmos, capable of extraordinary things. The Apollo program's influence can still be felt today in the technologies we use, the scientific knowledge we've gained, and the ongoing exploration of space. It stands as a testament to the power of human ingenuity and the desire to reach beyond our limitations. As we conclude this journey through one of humanity's greatest achievements, the Apollo 11 moon landing, it's important to reflect on the magnitude of what was accomplished in 1969. The first successful moon landing marked the pinnacle of the Apollo program, but its significance goes far beyond the technical feats of engineering and space exploration. It was a defining moment in human history, a victory for science and innovation, and a symbol of unity during a time of global division. The Apollo 11 mission was the culmination of years of hard work, ingenuity, and courage. It represented the triumph of human perseverance, with thousands of engineers, scientists, and astronauts coming together to solve one of the most complex challenges humanity had ever faced. The journey to the moon wasn't just about pushing the boundaries of space travel. It was about pushing the boundaries of human potential. From the thunderous launch of the Saturn V rocket to the tense moments of the Eagle's descent onto the moon's surface, and finally, to Neil Armstrong's first step, the mission captured the imaginations of people around the world. It was a moment when the entire planet came together to watch in awe, as human beings set foot on another world for the very first time. Armstrong's words, "That's one small step for man, one giant leap for mankind," became an enduring reminder of the collective human spirit. The moon landing's legacy has continued to shape the world in ways both tangible and intangible. The scientific discoveries made during the Apollo missions have expanded our understanding of the moon and its history, while the technological advancements born from the space race have transformed industries, driving innovation in medicine, computing, and communications. But more than anything, the moon landing inspired generations to dream big, to look up at the stars and believe that anything is possible. The Apollo 11 mission also left us with a profound perspective on Earth itself. The iconic Earthrise and blue marble images taken by astronauts during their lunar missions showed us the beauty and fragility of our home planet. From the vantage point of space, Earth appeared as a small, delicate sphere, suspended in the vastness of the cosmos, a reminder of our shared humanity and the need to care for the planet we call home. As we continue to push the boundaries of space exploration with new missions to the Moon, Mars, and beyond, we carry with us the legacy of Apollo. The spirit of exploration, curiosity, and discovery that defined the Apollo era continues to inspire today's scientists and engineers as they strive to unlock the mysteries of the universe. But beyond the technology, beyond the science, the story of the moon landing is, at its core, a story about people. It's a story about the men and women who dared to dream the impossible and turned that dream into reality. It's a story of collaboration, resilience, and determination in the face of challenges that seemed insurmountable. And it's a story that reminds us that, no matter how vast the challenges may be, when we come together with a shared purpose, there are no limits to what we can achieve. As we round off this exploration of the moon landing, let the story of Apollo 11 serve as a reminder of the power of human ingenuity and the endless possibilities that lie ahead. The journey to the moon may have been one small step in the grand history of the universe, but it was a giant leap for mankind, one that will continue to inspire us for generations to come.